Hi everyone, it's Dr. Marks, and our topic for today is efficiency, but specifically we want to apply these concepts of efficiency to the model of perfect competition. Now, we're going to be discussing two types of efficiency, and those types of efficiency are productive efficiency and allocative efficiency. So we're looking to see if a firm is what we're going to call productively efficient or allocatively efficient. Now, as I've said, for this lecture, we're going to apply the idea to perfect competition because we just finished up that model and now we understand it. But please understand that efficiency isn't an idea only applied to perfect competition. We're going to apply it later to the model of monopoly. And what we really want to understand is we want to get this idea of what types of firms are efficient and which ones are not. So remember, we've been working with this spectrum of market structures that goes from perfect competition to monopoly. And what we're going to see is that not every one of those types of firms are efficient in both of these senses. So let's get started. We're going to start by talking about productive efficiency. Now, when we talk about productive efficiency, we're asking if the firm operates at the lowest average total cost possible. So, do they operate at the lowest average total cost possible? Now, for this to be true, you agree that they must be operating at the minimum average total cost, right? Well, remember, what shape is average total cost? Average total cost is U-shaped, right? So if average total cost is U-shaped, then we have to be at that very bottom of that U. Now, this is clearly the best situation for consumers because it's going to keep prices as low as possible. So just think through this for a second. If you're a firm and you're producing at some higher point on average total cost, that means your costs aren't minimized. That means you're operating at some higher cost structure, and therefore you're going to have to pass some of that cost on to your consumers in the form of higher prices. So for you and me as consumers, we want firms to be operating at the minimum of average total cost. So let's take a look at this graph right here. Now, hopefully you're looking at this and saying, I know exactly what this is. This is a perfectly competitive firm in the short run. Now, you might be thinking, well, how does she know it's short run? Well, the reason I know it's short run is that they're making supernormal profits. And what do we know? Can a firm make supernormal profits in the long run? No, because remember, we're going to be talking about entry, and firms are going to come in and compete those supernormal profits away. So I'm looking at this graph and I know that this firm is perfect competition, right? It's got that horizontal demand curve. And I know that they're making supernormal profits. So let's quickly review that. First, I've outlined for you the total revenue box. Everyone agree that that green box is total revenue. How did we find total revenue? P times Q, right? So total revenue, P times Q, gives me that green box. And then do you agree that total cost here is shaded in blue? So revenue is outlined in green, but total cost is shaded in blue, right? We went up to the average total cost curve. Here it's just called average cost, but it's really average total cost. They went up to the average total cost curve and over. That leaves us with a situation where total revenue, our green box, is greater than our total cost, which comes from the blue box. So hopefully that makes it clear to you that we're making economic profits. And we're making economic profits here equal to the pink area. So that tells me economic profits are greater than zero, which means supernormal profits. And again, we can only do this in the short run. So we want to ask the question here, is this firm operating at the minimum of its average total cost? Well, let's look at the arrow and we see no. Does everyone agree that they're actually operating to the right of this point, right? I've got to look at Q star, and Q star is definitely not where average total cost is minimized, right? So we would have to say that at this point right here, this firm is not productively efficient. Sorry, I have a little typo there. It's not productively efficient in the short run, right? And so make sure you understand, to be productively efficient, it would require us to be operating at an output level where that red arrow is, but we're not there. But what about the long run? Because this is the short run, right? And we need to think about what's going to happen in the long run. So let's remind ourselves, we've got supernormal profits, and they're going to attract entry, right? But firms can't enter in the short run. They have to wait till the long run. So finally, the long run starts, and these firms enter. And think about what we know. When firms enter, that's going to be a market supply increase, right? So our market supply curve is going to shift to the right. And when our market supply curve shifts to the right, that drives prices down. Now, I'm not drawing that part of it because this is review. You already know this. But it drives price down. And remember that perfectly competitive firms are price takers. So if they're price takers, they're going to adopt the lower and lower price. And so when they do, their demand curve is going to fall. So do you see my green arrow there? They're adopting the lower and lower price. That demand curve is going to fall, and ultimately they're going to end up on something like this purple pinkish colored demand curve that I've put in here for you, right? So whatever happens in the short run, even though we didn't see productive efficiency there, that short run's not going to last forever, as we said, because firms are going to enter. So let's look at the long run. We know that this firm is in long run equilibrium. And how do we know? Well, because we're sitting at zero economic profits, right? We have a situation where total revenue exactly equals total cost, right? So take a second with your finger and just make sure that you can find total revenue, P times Q, so it's going to be that box, height of P, length of Q, and then do the same thing and find average total cost. Take your finger from Q star, go up to the green average total cost curve and over, and you see it's the same box. Now, don't be confused that they keep calling it average cost. The only reason is that they don't have it divided between average total and average variable. Doesn't matter. It's the same thing. It's our average total cost curve. So, have I convinced you? Total revenue equals total cost. We have zero economic profits here, right? So, now let's ask the same question. Is this firm operating at minimum average total cost? Is it? Well, hopefully you answer yes. We see that we're now at an output level Q star where Q star is at the minimum of average total cost. So now we do have productive efficiency. So in the short run, no, but in the long run, in perfect competition, yeah, we do see that we're going to be productively efficient. So the bottom line here is that what we're saying is that we're at the size that generates productive efficiency. The firms are operating at a size that reduces average total cost as much as it possibly can, and that's good for you and me as consumers. All right, so productive efficiency. Do you agree with me? It's pretty easy because all you're having to do is figure out where are we on the average total cost curve. So now let's move on to the other type of efficiency. We need to talk about allocative efficiency. Now, guys, allocative efficiency is just a little more confusing, but I promise you, you've got all the tools in your toolkit that you need for this. So allocative efficiency looks at the optimal allocation of resources. Oh my gosh, another typo. Optimal allocation of resources. So optimal allocation of resources. In other words, we don't want too much produced or too little. So it's kind of like Goldilocks and the Three Bears, if you want to think about it that way. We don't want it too hot, we don't want it too cold, we want it just right. So what we need to figure out is, what does that mean? Too much, too little? What is just right? So we need to find this optimal level of output. Now, this ties into the rule of optimality that you learned much earlier in the semester. So, rule of optimality tells us that if marginal benefit is greater than marginal cost, then it's rational to increase an activity. So in this case, produce another unit. But if instead marginal benefit is less than marginal cost, then we've done too much. We've gone too far. We've overproduced, and we want to rein it in. So we know that on our graph we have marginal cost. So if I want to think about allocative efficiency where I compare marginal benefit and marginal cost, I already have half of what I need, because marginal cost is a curve on our graph. But we also need marginal benefit. So how do we think about marginal benefit here? Because do you agree, we do not have a curve called marginal benefit. So what do I need to do here? Well, we need to realize that price is a measure of marginal benefit. Price. So we can use price. Guys, do we have price on our graphs? Sure do, right? So what we're saying is that if people are willing to pay $10, if that's the price and people are willing to pay $10, then what that tells me is their marginal benefit is equal to $10. So I can infer from price that that captures people's marginal benefit. So we need to reframe marginal benefit versus marginal cost. Instead of marginal benefit, we're going to look at price versus marginal cost. So all we've done is reinterpreted the rule of optimality to be price versus marginal cost, whereas before it was marginal benefit versus marginal cost. But it's still basically a rule of optimality, right? So let's assume that marginal cost of production for our operation is $15. But society's willing to pay $20. So marginal cost of production is $15, but society's willing to pay $20. Well, I should be able to, from this, determine that means that people have a marginal benefit of $20. So I'm in a situation here where marginal benefit of $20 is greater than the marginal cost. So what does that mean we should do with our output? If people will pay $20 and it only costs us $15 to produce more, then what should we do? So take a look at that. Do we want to increase output? Do we want to decrease output? Well, hopefully you realize that it's in society's best interest here to produce more of good X. And so that's what should happen. Output should go up. And if it does, that would be a win-win. So let's think about that for a second. Firms would sell more and they would get more money, so they're winning. But society also gets more X, and that's something that they want. So if people want X, then it's a win-win. Firms can make money, giving society something that it wants. So let's come back to this graph, which again, remember, is our long-run equilibrium. We need to ask a question. Is this firm producing a level of output where price equals marginal cost? So take a look at that for a second. Is this firm producing a level of Q where price is exactly equal to marginal cost? Well, the answer is yes, it is. So the firm here is allocatively efficient, right? In other words, this firm is setting the optimal output for society. This firm shouldn't produce any more or any less. So not too much, not too little. If you're having any trouble understanding this at all, let's focus on this point where they all intersect. So take your finger and trace the price line across and find where the price line intersects marginal cost. Do you agree that that happens at Q star? So we're producing Q star, and if you look at it, trace Q star all the way up, you see that at Q star, the price line, the black line, intersects the marginal cost line, which is the blue line. So clearly price has to be equal to marginal cost. Now, remember here something very important. Firms maximize their profits if they select an output where marginal revenue equals marginal cost, right? So remember that shortcut rule, the rule that we said, look, if you operate this way, if you set your output this way, you're going to maximize profits or minimize your losses. So I've even drawn a red arrow with the little yellow note. Hey, here's our shortcut rule. Find where marginal revenue equals marginal cost. But doesn't that also give me the point where I'm going to see marginal revenue equal to price? So marginal cost equals marginal revenue equals price. Everything is pretty much equal at this point. So when I use this shortcut rule, it guarantees that we're going to be allocatively efficient, right? So all I have to do here is substitute in price, and you see that we have price equal marginal cost. So again, if that's not clear, let's back up because this is a really important point. I have to do this the old-fashioned way, sorry. All right, so remember, that's our shortcut rule. Marginal revenue equals marginal cost. So remember what we said. Look at the red arrow, and we see that price equals marginal revenue, right? That's that horizontal demand curve, that price line, the black line. So if marginal revenue equals marginal price, then all I have to do is plug in price in for marginal revenue, and that gives me price equals marginal cost. So we are allocatively efficient. So when we use this decision rule, guys, we get allocative efficiency. That was a little long-winded, but hopefully you followed all that. All right, so let's keep in mind, guys, that there's also an implication for consumer and producer surplus. Now, we look at that at the market level, right? So when we talk about consumer and producer surplus, we're looking at the market. So let's take a look at these ideas. In other words, we want to look at the economic pie that society perceives, right? The economic pie is the consumer surplus and the producer surplus added together. And we want that to be big as possible, right? So, do you agree with me? Look at the left graph, that consumer surplus has been shaded in green. Remember, consumer surplus is the difference between what you're willing to pay, which comes from your demand curve, and what you're asked to pay, which comes from price. So all of that is that savings, money you were willing to spend that you didn't have to spend. But then, look what I've just done. I've added some purple squiggle, and we see producer surplus shaded in purple. So remember, producer surplus is the difference between the firm being able to cover its marginal costs, which comes from that supply curve, right? That's the minimum that they will accept, and what they actually get paid. So I'm willing to take a price that covers my marginal cost, but you're giving me more than that, and that creates the purple consumer surplus. All right. So we've got our consumer and our producer surplus. But also notice here that we have no deadweight loss, remember? So think back what we did a few weeks ago when we looked at price controls, and we had that triangular area, that surplus that used to belong to people before the government put in price controls, but then the surplus disappears. Well, we don't have that here, right? There's no deadweight loss. So that's a good thing. That means that we're making the economic pie as big as possible. The economic pie is maximized. So what that means in a nutshell is that all mutually beneficial exchanges are taking place. Remember, deadweight loss comes from there being these beneficial trades, but they don't get to be made because of price ceilings and price floors and those kinds of things. But here, all of the mutually beneficial trades that would be a win-win, those trades are taking place, and that's what maximizes the economic pie. So in summary, we see that perfectly competitive firms are efficient. So when we think about why we like perfect competition, well, it's good for you and me. It's efficient. And it's efficient in both ways, right? In two different ways. It's productively efficient and it's allocatively efficient. So we're going to be doing the same kind of analysis for a monopoly to see if they're efficient as well. All right, let me know if you have any questions. Thanks for listening and have a great day.